Number 11. Okay, what do we have here? Well, the first thing I see is down below, because we've got to get a common denominator. This n squared plus 3n minus 10. I got to break him up. So what is he going to break up to? Well, looks like what's going to multiply together to give me 10? You got to have a difference for 3. That's a 5 and 2. So again, for 10, we have 1 and 10, 2 and 5. I know it's 2 and 5. It is a negative 10, so one piece is negative. We need to create a plus 3. That means it's going to be a plus 5 and a minus 2. Those multiplied will give you negative 10. Put together, they give you positive 3. So n minus 2, n plus 5. Okay, what is this guy? Well, an n factors out, and you have an n minus 2. They all need the same thing. We have an n here. We have an n minus 2, n plus 5, n minus 2. So it looks like the common denominator for all of them is simply going to be an n minus 2, and an n plus 5. So what does this guy lack? He lacks having an n minus 2 and the n plus 5. So we're going to multiply the top here by an n minus 2, n plus 5. This simply lacks just being multiplied by an n. So that 12 up top will get multiplied by an n. And over here, he has the n minus 2, but he doesn't have the n plus 5. So that will get multiplied by the n plus 5. All our denominators are exactly the same now, so we can set the left numerator equal to the right numerator. So we do 1 times the n minus 2, n plus 5, plus the 12n has to equal the 1 times the n plus 5. Well, let's go ahead and multiply this. Well, we already know that's just this n squared plus 3n minus 10 plus 12n has to equal 1 distributed through, just gives you back the n plus 5. So all we got to do now is just solve for n, and we will be set. But we have an n squared in here. This is going to be interesting. Let's see what happens. Well, I'm going to end up moving everything over to the left to get this set equal to 0. To do that, I'm going to have to subtract an n and subtract a 5. So I'm going to subtract an n and subtract a 5. Now, one thing I did poorly that I shouldn't have done is I should have put the 3n plus the 12n together first. So really, let's do that. Those put together first would have been 15n minus 10 equaling that n plus 5 over here. Now let's go ahead and subtract our n and subtract our 5. It makes it a little cleaner. Let's see what we get. We get an n squared plus 14n minus 15 equals 0. The reason I did that is because I noticed I was going to have an n squared. So I knew I might be able to factor this. So we want to try and factor this and see what it might break down to. Because right now I couldn't tell you what squared plus 14 times the number minus 15 equals 0. I don't know. Pick a 1, pick a 2. I don't know. Actually, if you pick 1, it will work. But we're going to figure it out. So what do I want to do? I could do the quadratic equation. That'll work every time guaranteed. But I can factor this. What multiplies together to give me negative 15? 1 and 15, 3 and 5. I notice that these have a difference of 14, which is what we want. And we want to create a positive 14. So I can make him positive, him negative. So negative 1 times positive 15 is negative 15, yet put together gives me the positive I want. So this actually factors down to an n minus 1, n plus 15 equaling 0. So now I can just set each piece. Either this is 0 or this is 0. And solving it, you can see n is add 1 to both sides. I get 1, subtract 15 from both sides, negative 15. Those are the two solutions that'll work here. Now, technically, we should go back and plug 1 in and see that it works. It does. Take negative 15, plug it back in, see that it works. It does. I checked them. So there you have it. We don't have any extraneous solutions. 1 works, negative 15 works. Very tough problem because you got to be able to do everything, and then you got to realize, wait a second, let me get the n squared by itself set equal to 0 and then factor it. Tough problem, but doable.